Right, starting lesson 1.4 on solving systems of linear equations. So basically all we're trying to do is come up with mathematical strategies for finding the point of intersection, if it exists, for two linear equations. Um, there are some really good and simple strategies for, um, again, lots of really good online Desmos strategies, TI-83 strategies, and those are great for SAT and those sorts of things. But to understand the process, we're going to go through solving them without the use of the calculator. So first up, we'll be graphing. Right, we're going to graph these two equations. So we're going to graph this one, y equals negative x minus 1. I'm going to start at my y-intercept of negative 1, and it has a slope then, here would be also negative 1, right, because it's negative x, right? So the points are going to go like this, down 1, right 1. Right, and I can connect those with a straight line to the best of my ability. Second equation, y equals x plus 1. So my y-intercept is there at the 0, comma 1. And then this one has a slope of positive 1, right? Because it just says y equals x, so there's an implied 1 right there, right? So up 1, right 1 for my slope. And I see I get a point of intersection right here. Right, so the solution then is negative 1, comma 0. So that's just a quick review of graphing. Talks about look for where the graphs intersect. There are three options, right? This would be one of the options where you get one point of intersection. So, right, our three options are one point of intersection. The other option would be no points of intersection. The two lines are parallel, so they never intersect, no solution. And then the last option is where they are the same line, and they have an infinite number of solutions. So those are the three things that can happen when we try to find points of intersection, also called solutions to systems of equations. The main strategy we're going to focus on today, substitution and a little bit into elimination. Here we see that we have two y equals equations, right? They both are equal to y. Right? So I know that y is equal to 2x minus 15. I also know that y is equal to 5x. So what I can do then is set those two equations equal to each other because they are both y equals, right? Y is two different things, so I'm going to say those two equations. I'm trying to find where they are equal. So I'm going to use just basic solving strategies now, right? Moving over the 2x, subtracting the 2x away. And then I can divide away this 3, right? Should have changed the colors, but so I get the x solution of negative 5. Right? But that is only part of my solution, because when you are dealing with solving systems of equations, you want to know the x and y value, and I only know x. So what I'm going to do is pick one of the two equations that I started with and substitute my x value into it. And I'm going to pick the y equals 5x because it is the simplest equation. No point in doing extra work. right? So I said y equals 5x, and I know that x is negative 5. So I know that my y portion of this solution is negative 25, right? So just some substitution, and then we substitute actually twice. We substitute and make the two equations equal, and then we have to substitute in again our partial solution here back into one of the equations. So here is another example of how I can use substitution. I don't have an 2x equals or 2y equals equations, but I do know that x is equal to negative 1 plus 2y, right? They tell me that x is the same as negative 1 plus 2y. In the second equation, 3y equals x plus 4, I can trade this x out for the negative 1 plus 2y because that is the same thing as x, right? It tells me right here, x equals, x is the same as negative 1 plus 2y. So I can rewrite this as 3y equals, and instead of x plus 4, I am going to use this value here for x, and then the plus 4. Okay, so now I am going to work on isolating the variable, right? Before I do that, I'm going to combine some like terms here. I get 3y equals negative 1 plus 4 is 3 plus 2y. And then I would move away this 2y, right? Subtract 2y from both sides. That leaves me with y equals 3. Okay, and just like the last problem, this is only part of my solution. I only have the y part of the solution, and I need the x part as well. So I am going to use this first equation, since it is formatted for x equals, to find that x value. Right, so x equals negative 1 plus 2y, and I learned already that y is 3. Right, so I substituted in a 3 for y. So just do some order of operations work here, right? So I get x equals 5, right? X equals 5. So we are going to jump into some elimination now. So we are going to try to solve these two equations, and notice we don't have any, right? We don't have two y equals equations. We don't have one part that I can solve into the other. And so these two would honestly be a great solve on Desmos, right? Desmos could solve this up very quickly. But if you are asked to show your work, you're going to need to do some calculating on your own. You could work one of these into x equals or y equals. It's not going to be a very clean conversion, but you could do the math. Ideally, elimination, if you have to do this by hand, is going to be what you want to do. So to eliminate means to get rid of something. So we are going to work to eliminate a variable, right? And here I see that they both contain a 6x, right? They both start off with 6x. So if I were to then subtract these two equations from each other, okay, and they're already stacked and lined up, like you learned how to subtract in second grade, and we are just going to go a term at a time. We're going to start right here. What is 6x minus 6x? Well, it is 0x, right? And in reality, I wouldn't even write that down because 0 times x is 0. That is the elimination that we needed to happen, right? We eliminated the x variable. Okay, but I'm going to continue on subtracting. 5y minus a negative 7y. And you have to pay attention to signs here. 5y minus a negative, so that's going to be plus 12y. And then I have 4 minus a negative 20. So that would be minus 4 minus a negative 20, that's going to give me 24. Right? The two negatives make a positive. So just, this is really what you should have written then in this step, right? We didn't need this part. And then I can continue to work to solve for y, right? Divide away the 12, I get y equals 2. This is half of my solution, right? I know that y is equal to 2. And now we are just going to pick one of the two original equations and work to solve it for x. And it's kind of just a pick. Neither of these are super friendly, so I'm just going to go with the top equation. 6x plus 5y equals 4. So 6x plus 10 equals 4. And then if I subtract away this 10, I get 6x equals negative 6. So x equals negative 1. Okay, so that is elimination. Let's look at one more elimination example. And this one is a little bit more complicated because we don't have any terms that are the same, right? I have 3x on top and I have 2x on bottom, and I have 2y on top and 6y on bottom. Okay, so I don't have a quick route to elimination, but what I can do is I can multiply all of an equation by something, by a coefficient. And if I multiply this entire top equation by 3, all three terms get multiplied by 3, that 2y multiplied by 3 is going to become 6y, right? So I get 3 times 3x is 9x, 3 times 2y is positive 6y, and then 3 times 9 is 27. Now I have 6 y's that are the same. So I'm going to subtract these again. I get 2x minus 9x is negative 7x. My 6y minus 6y is going to cancel, and then I get 6 minus 27, and that is going to give me negative 21. I'm going to work to isolate x, so I get x equals 3, right? Again, half of my solution. So I pick an equation and I substitute in 3 for x. So I'm going to go with that second equation, 2x, which is 3, plus 6y equals 6. So 6 plus 6y equals 6. And then if I subtract away this 6, right, I get 6y equals 0. So y is equal to 0. Right, so that is it for our lesson. You are going to work the problems on your own now and get your assignment completed.